Okay, we now have the last section in chapter 7. And this one is solving systems of linear inequalities. So we have graphed linear inequalities before. That's when we involve with the dotted or solid lines and the shading. But now we're going to graph a system. So what that requires is to graph each inequality individually. And then you're going to find where they overlap, or the intersection of the shading. It's not going to be as specific as section 7.1 where we're looking for a very specific point. This time we're just looking for a shaded region where they overlap. So it's important for this section to be careful with your shading. And what I'm going to do is use different colors and then see where the colors overlap, which is a good plan. Otherwise, I'm going to show you how to make just general different shading techniques to see where those overlap. So graph the system of inequalities. I'm going to graph the top one in green. The y-intercept is 0, -2, and the slope is -1. And this is going to be a dashed line because it's not equal to for the y. So I start at 0, -2, and then I go down 1 over 1. So this is what my line would look like. Okay, and then I need to pick a point and figure out where I'm shading. I pick 0, 0 since that's not on my line. 0 is greater than -2, which is true, so I'm going to shade above. Now what I'm going to do is do lines going the same direction as my line, right against it. So if you don't have multiple colors, that's probably what you want to do, is do the lines one direction and then for the other line do a different direction and see where the lines intersect. The bottom one has a y-intercept of 0, 6 and slope of 3. And it's going to be a solid line. So we actually do need to go up a little bit on this graph. 1, 2, 3. Start at 6 and then go up 3 over 1. If I test 0, 0 to see if I shade that side, 0 is less than or equal to 6, which is true. So now what I wanted to do in the end was to find out where my two different colored lines intersect, or my different direction lines, and they intersect in this whole section of the graph. So for my final answer, what I want to do is darkly shade that region where they overlap so I can tell, or the person grading my homework can tell, what section is the correct section. And make sure that you don't cover up your dashed lines so that they can still tell that you knew they were supposed to be dashed. Okay, it doesn't have to be perfect, just as long as we can see what corner of the graph is supposed to be shaded all the way. Okay, this time we have 3. Remembering that the top inequality, the one that does not have an x, that one, it's a horizontal. And solid, so it's going to be right here at -1. And what is greater than or equal to -1? Everything above it. Okay, and the second one, if it's just an x and no y's at all, that's going to be vertical. At 2, and it's going to be -2, I'm sorry, and it's going to be dotted. We scroll down a little bit so I can see the whole thing. And where is x greater than -2? That's to the right. And the last one I need to put in slope-intercept form. Subtract the x, divide by 2. So my y-intercept is 2. Slope is -1/2. That's a solid line. Okay, I know my line wasn't exact. You want yours to be as exact as you can, so you should use a straight edge. And I'm going to test 0, 0. 0 is less than or equal to 2. That is true, so I'm going to shade the side that includes 0, 0. Now I'm looking for where all of my different line directions or colors intersect. That happens right here. Again, I'm not covering up. Let's see, it's all the way down there. Okay. I'm not wanting to overlap the green dotted because we want to be able to tell that that's dotted. Okay. Two examples down here. A, our y-intercept is -4 and slope is 1, but it's a dotted line. Y0 is less than -4, which it is not, so I shade on the side that does not include the 0. And the other one has a y-intercept of 3 with a -1 slope, solid line. 0 is greater than or equal to 3, which is not true, so I shade the other side. And then where they overlap is my answer. Okay, B has 3, the top one in black. It has a y-intercept of 2, slope of -1, it's solid. Zero is greater than or equal to 2, which is not true, so I shade above. Green will be the horizontal, y is less than 4. Then the red will be x is less than 3. Our overlapped region is right here. What you should not do is graph just the inequality lines and then try to figure out where the overlapping region is. You should not do that. You need to do what we did, where we graph each inequality and shade at that time and then just see where the shading overlaps. So if I only see that blue region in the middle with no other shading, that's complete luck because it does not always work like that. So you really should not use that method. Okay, this next one. Y is greater than or equal to x. That's a y-intercept of 0. Dotted line, -1 for your slope. If I can't test 0, 0, I'm going to test 1, 1. 1 is greater than or equal to -1. That's true, so I shade the side that includes 1, 1. Y is greater than or equal to x minus 4. Zero is greater than or equal to -4. That's true. Y is less than 5. So where do we overlap? Looks like, oops, let's do black so we can tell. Right here. And our last question is involving, this area is going to be the shaded one. We need to figure out what these equations are, these inequalities are. So the easiest one whenever you have to figure out what the inequalities are after it's already graphed is to use the horizontal or vertical ones first. Those are always the easiest. This is solid, so it's going to be y something or equal to, and it's at 3. And you can always tell with the vertical or horizontal lines whether it's going to be greater than or less than just based on where it's colored. So if my line is y equals 3 and I'm shaded above, that means we have to be greater than or equal to 3. And then with the other line, what I need to figure out is its y-intercept and its slope. Y-intercept should be at 1. It's a little off because I had to improvise. And our slope is 2. I can figure that out either by looking on the graph, assuming go here to this point, that's up 2 over 1. Or I can just pick 2 points and calculate the slope that way. So if this was an equation, my equation would be y equals 2x plus 1, but it's not. We need to figure out what the inequality symbol is. So I would just kind of guess one of the directions. I'm going to say greater than or equal to. If I guess greater than or equal to, and I test 0, 0, that should come out false because the 0, 0 side is not shaded with this line. So 0 is greater than or equal to 1. That's not true, which is good because we didn't want it to be true. So that's how we know that that's the correct direction for our inequality symbol. And that's all we have for section 6 and chapter 7 on systems of equations and inequalities.